Welcome to Study Loop.
So in this problem, we are given with the decomposition reaction of calcium carbonate, which is a solid, and that gives us calcium oxide, which is also a solid, and carbon dioxide gas. We are given the Kc value for this reaction at 900 degrees C, and we are given three reaction mixtures for this reaction, and we have to find out if the amount of calcium carbonate will increase, decrease, or remain the same as the system approaches equilibrium. So to find that out, what we have to do is first we have to set up um, the expression for the reaction quotient for this reaction, and then we have to compare the reaction quotient value with the Kc value, and based on the reaction quotient value greater, equal, or smaller than the value of Kc, we'll be able to say whether the concentration or the amount of calcium carbonate will increase, decrease, or remain the same. So the reaction quotient expression, if we consider it as QC, it will be equal to the gaseous products concentrations over the gaseous reactant concentrations. But here you can see that our reactant is a solid and one of our product is also solid. That means these pure solids will not be included in our reaction quotient expression. That means only the concentration of carbon dioxide gas will be present in our reaction quotient expression. So the QC will be equal to the concentration of CO2. Now we have to find out the concentration of CO2 in each case, and based on that, and the concentration of CO2 will be our value of QC, and then we'll compare our QC value with Kc value. So for first one, we are given, in each case we are given the mass of CO2. So in the first one, our mass of CO2 is 4.25 gram. So what we have to do to find out the concentration of CO2 is first we have to find out the number of moles of CO2, which will be mass over molar mass. So the mass of CO2 given for the first case is 4.25 gram over the molar mass, which is 44.01 gram per mole for CO2, and this will give us a value of 0.096 mole. Now we have to divide this number of moles by the volume of the reaction vessel, which is 10 liter, to get the concentration of CO2. As we know that concentration is number of moles over volume, so the concentration of CO2 will be 0.096 mole over 10 liter, and this will give us a value of 0.0096 molar. That means the value of QC is equal to 0.0096. Now, if we compare the value of QC with the value of KC, we can see that the value of QC is smaller than the value of KC. And we know that if value of QC is smaller than the value of KC, so the value of Kc is actually the value of Qc at the equilibrium. That means to reach the equilibrium Qc value, which is our Kc value, we need to increase our value of Qc. And to increase our value of Qc, what we have to do is we have to increase the concentration of CO2. And to increase the concentration of CO2, we need more calcium carbonate to decompose. That means um, in this case, in case of part A, to reach the equilibrium, the amount of calcium carbonate will decrease. So, in answer to our question A is the amount of calcium carbonate will decrease. Now, in case B, again we have to calculate the concentration of CO2, which will give us the reaction quotient value. And again, to find out the concentration, first you have to know the number of moles of CO2, which will be the mass over molar mass. So the mass this case of carbon dioxide is 5.66 gram over the molar mass 44.01 gram per mole, and this will give us a value of 0.129 mole. And then if we just divide this by the volume, we'll get the concentration of CO2. Volume is 10 liter. If we divide the number of moles by 10 liter, it will be 0.0129 molar. That means the value of QC will be 0.0129. And again, if we compare this value with the Kc value, you can see that it is greater than the Kc value, which is 0.0108. That means in this case, our QC value is greater than our Kc value, and that means if the reaction approaches equilibrium, that means it will approach this value from this value, and that means we need to decrease the value of QC to reach the value of Kc, or to reach the equilibrium. And if we need to decrease the value of QC, we need to decrease the concentration of carbon dioxide. And if we need to decrease the concentration of carbon dioxide, we need some calcium oxide to react with carbon dioxide, and that will form some calcium carbonate. That means it will eventually increase the amount of calcium carbonate. So in second case, the answer is the amount of calcium carbonate will increase. Similarly, in case of C, if we find the value of QC, which will be again the concentration of CO2, we have to find out the number of moles of CO2, mass over molar mass. So the mass here is 6.48 gram, molar mass is 44.01 gram per mole. From here we can get the value of number of moles, which will give us a value of 0.147 mole. And from here we can get the concentration of CO2, just dividing this by the volume, which is 10 liter, and it will give us 0.0147 mole per liter or molar. That means the value of QC will be 0.0147. Again, if we compare this with the value of Kc, we'll see that it is greater than the value of Kc, which is 0.0108. That means if we need to reach the equilibrium, we need to reach the value of Kc, and that means we need to decrease the value of the QC to value of Kc. That means we need to decrease the value of QC, and that again mean we need to decrease the concentration of CO2. And if we need to decrease the concentration of CO2, again we need some CO2 to react with the calcium oxide to produce some calcium carbonate, and that means in this case also the amount of calcium carbonate will increase as the reaction approaches equilibrium. The answer to the third one is also the amount of calcium carbonate will increase.